A heavy power tool is highly capable, but it's completely useless until a human hand actually decides to pick it up and pull the trigger. For years, artificial intelligence in the automotive industry worked exactly the same way. The software possessed massive processing power, but it sat entirely dormant until a human prompted it to act. At CES 2026, the industry saw the first major commercial wave of AI dealer assist tools. Progressive dealer groups quickly deployed these early systems into their actual retail environments to automate lead capture, book test drives, and handle standard service scheduling. This chart shows the immediate impact of those initial deployments. Comparing the human-only baseline on the left to the AI-assisted workflows on the right, pilot programs reported an efficiency spike of 30 to 50% on targeted repetitive tasks. But those early tools were narrowly focused on single objectives. They required constant supervision to operate correctly, and they relied entirely on human employees to orchestrate the broader workflow and dictate the next step. Because of this dependency, dealerships eventually hit a hard ceiling on efficiency. A program could generate a highly accurate trade-in valuation in milliseconds, but that data sat idle until a human employee reviewed it, opened a separate communication tool, and emailed the customer. The industry had successfully adopted advanced computational algorithms, but its actual operational speed was strictly throttled by human reaction times. The AI lacked the agency to initiate action on its own. By 2029, the underlying architecture shifted. Software moved from being a reactive tool waiting for instructions to an autonomous agent operating as a persistent participant within the organization. To see how this changes daily operations, look at a modern service scheduling workflow managed by an AI agent. This agent operates entirely in the background, continuously monitoring vehicle telemetry, live service bay capacity, and global parts availability. If telemetry indicates an upcoming sensor failure, the agent secures the part, books an open bay, and contacts the owner directly to confirm. 3 years prior, a dealership chatbot would sit inert on a homepage, doing nothing until a customer initiated the interaction by typing a question about their brakes. Automotive workflows transitioned from linear sequences initiated by human managers into continuous, self-driving cycles of analysis and execution. Introducing software that pursues multi-step objectives and executes tasks independently forces a redesign of leadership structures. Human managers are no longer spending their days directing teams of people to execute individual tasks. Their required skill set has shifted towards system design, orchestrating a shared collaborative workflow between human staff and autonomous agents. This dynamic requires a strict operational framework known as agent governance. First, organizations must establish clear agent authorities. They have to define the exact financial and operational boundaries within which the AI is legally and procedurally allowed to make decisions on its own. Next, they must map out escalation protocols. If a customer interaction falls outside defined parameters, or a logistics delay exceeds a risk threshold, the software immediately defers the exception to a human supervisor. As routine cognitive labor, like data entry, reporting, and scheduling, migrated to AI agents, human roles shifted upward. Staff redirected hours toward complex negotiations, creative problem-solving, and high-touch relationship building. Despite early industry predictions, massive job losses did not materialize. The total headcount decreased only modestly, while the individual capability, reach, and output of every single employee multiplied. The modern dealership operates as a true hybrid organization. Human judgment and machine persistence act at a single, highly coordinated operational unit. This seamless collaboration was only achieved by the specific automotive organizations that spent the years between 2027 and 2028 architecting unified data environments. An autonomous agent relies entirely on global, unsiloed organizational data. It cannot accurately monitor bay capacity, predict inventory needs, or communicate effectively if the necessary numbers are locked away in disconnected legacy software. Dealer groups that built those intelligence pipelines gave their agents the information required to function. Organizations that skipped that structural phase found themselves deploying sophisticated autonomous agents that couldn't execute tasks simply because they couldn't see the whole picture. Those successful local implementations are now scaling globally, expanding well beyond the retail floor. What happens when these autonomous retail nodes start forecasting demand, negotiating bulk pricing, and placing orders directly with other autonomous agents operating at the manufacturer and logistics levels? We are moving toward a global automotive supply chain where human orchestration steps entirely out of the transactional loop.